Hi guys, welcome to day 2 of Numpy. As we have learned yesterday about the basic concepts of whatever entails in the Numpy library, what are the basic functions and what are all the benefits that are to Numpy than using normal other data types such as lists and all. Okay. So today we will be just discussing 5 questions that we have picked out from different sites, which we feel would make you more familiar with the topics, which will make you more easy to use NumPy. Okay. See, in data science, machine learning, or any such branch of AI and ML, the point of these libraries is cleaning data, manipulating data, right? So if you don't have a firm grasp on how exactly their functions take place, how exactly they operate, then you won't be able to easily perform these tasks on a data. Okay, so these are the very few basic simple examples. Other than that, we'll recommend you guys to solve out the assignment that we have provided yesterday. Based on these questions, we'll give you another assignment today, which would be a level up to the questions that you would have gotten yesterday. Okay, and you would find them on the internet. It'll be easy, normal, generic questions actually. So that's that. Okay. So the point is, if everything is already provided on the internet, then why are we discussing it right now? We are discussing this because we have been talking about NumPy since yesterday, right? So if we talked about NumPy, we understood it using a few examples, then how about actually putting it into practice and seeing how it works? How am I able to use it differently? How is it so different from the basic building blocks that Python has already provided me? How does NumPy make it different? Okay. All right. The first question is given a space separated list of numbers, we have to print a reversed numpy array with the element type float. Okay. So it's quite a basic question, right? Given a list of numbers, we have to print a reverse numpy array with the element type of float. If we have to do this whole question with the basic building blocks that we have, what would we do? Um, Suppose I have a list and it's this. Okay, a simple list. Then it is asking me that I have to reverse this list. All right, I'll reverse this list as 1 second. I'll reverse this list using my slicing function. Okay, all right. Now I've reversed this list. Now it's asking me to change each individual element of this list to float. Okay, since I have to change each and every element, I should either use a for loop, kind of like this, right? For I in list. Okay. Mm, I would need to change it in case, right? Change. For I in range length of LSD, that means I would be my index value. Okay. So now I'll get each and every individual element. LSD of I should be is equals to, is saying to convert it into float, right? So I'll convert this whole into float as float LSD of I. Now I'll print my LSD. So this whole for loop and everything I have to do to convert this whole each individual element into float data type. Okay. Now, what happens if I have to do all of this just by using? my numpy. Okay. So first and foremost, I have to convert this into a numpy array, right? Then how do I do that? I'll do, I hope you guys do remember that if I've imported NumPy as NP, then I have nicknamed my NumPy library as NP. So whensoever I need to call a function or a method that is present inside of my NumPy library, I'll call is using NP dot that function or method name instead of writing NumPy directly. Okay, NP dot array. I'll give in my list name, and I can either do this. Okay, what this does is it has this np.array has this parenthesis in which it will take parameters. The first parameter would be a list or whatever input that we want it converted into a array format. It should be a numerical literal, right? So that thing is in the first parameter, and the second parameter, if left by default, would be taken in the values in 32. Okay, now if I specify it as float, it'll itself convert each element that I'm giving inside of this array function, this list value that I have given. It will contain each integer value or numerical value, right? It will convert each of those to float data type. Okay, see, I'll print out my array. 1.2.3.4.5. Okay, now I just need to reverse it. Okay, so arrays in NumPy has the same functionality, same slicing and indexing operation as we had with list and tuples. So I can do this. Okay, and it gets reversed, all right? Or I can use a built-in function that is present inside of my numpy library that is called flip ud. Okay, so how do we use flip UD? Okay, one second. If I run this again, it is not in the reverse order. So now how do I use flip UD? It will return a value. Okay. Remember, I have told you guys about the function of sorted and sort, that how one returns a value and does not change the original list, whereas the other one changes in place and returns a none value. So similar to that, this function np dot flip ud will return me a reverse array. So I need to assign it to another variable. I can assign it to the original variable so as not to waste my space, and see, I get it reversed. Okay. Now say I have specified it initially as float. Okay, now I feel like, okay, fine, I don't want it as float anymore. I want it as int, or okay, I just want to know what is my type, like each object, what's its type, right? So what do I do to check that? As we have a generic function in Python called as the type function. If we do that to our array, then it will print out in numpy and dot and in the array. Okay, that we know that this particular variable is a array. Fine. But what about the individual elements present inside of this array? How do I find out what's their data type as? Okay, I can do this. It gives me float 64. Now, if I have been given this function as d type, which tells me what the data type of each element is there a function which can change it? Like it can change the element data type. Yes, there is. There is that data type present, but again, you would need to reassign it. and put in, I'll just put in int, okay? And then let's get our array. It becomes an integer. Okay, I hope that's understood. Now let's move on to the next question. Given a space separated list of 9 integers, we have to convert this list into a 3 cross 3 numpy array. Okay, so how do we convert a list into an array? We just do this, right? np.array, and we put in the list value. Okay, so doing so, how do we get to know the shape? Basically, it will be the shape, right? Sorry, the dimensions of my array or matrix, since it's becoming 3 cross 3, so I'll call it a matrix. If I want to know what exactly is the shape of this, how can I know? Okay, uh, I'll assign another list here with 9 elements. I got these 9 elements. Now I'll convert these into my array. Okay. Now, what is exactly the shape of this whole array that I'm creating? This array one. We can see that there are 9 elements. Like, how do we know which element is considered as the is taken in the row or in the column, right? So how do we calculate that? There is a function inside of our NumPy library called as the shape function. Now, what it does is it will simply tell you what the shape is. This space simply indicates that there is a single column. There are 9 rows, okay, and there is a single column. Sorry, there are 9 columns and there is a single row. Column, comma, rows. Okay, it was my mistake. Sorry about that, guys. I'll just specify here that output of the shape method of your type n is equals to column, comma, rows. Okay, so this will make it clear. All right. Now they've asked us to specify the dimensions. Like they want us to convert this whole single dimensional array into a 2D array, right? So there are multiple methods in which we can do this. Either we just give the initial list as a 3 cross 3 array. Initially, only we give it as a 3 cross 3 list, so we'll get it as a 3 cross 3 array. But that is a very hard coded method, right? It is not something that should be practiced. Okay, so what we can do is we can assign this value. How will we assign this value? We did this. Okay, now we'll assign what values you wanted to have. Now let's check the output of this. This becomes a 3 cross 3 matrix. Okay, now other than this dot shape method, is there any other method? Yes, there is another method. Like initially we did this, right? In a single line we took in the list value and we converted the float. Similar to that, they have another function which is called as the reshape function in arrays. Okay. In that, we have our array present, okay, and we'll assign it as Okay, one second. I'll just do this so that you know that even now it is just a 9 cross 1. Like in mathematical terms, it's generally row cross columns, right? So I have a habit of saying it in that manner. Okay. Right now, there are 9 columns and only a singular row. Okay. So now I want it to be reshaped as 3 cross 3, right? One second. Yeah. All right. Just print this. This again becomes a 3 cross 3 matrix. All right. Okay. Remove rows in NumPy array that contain non-numeric values. Okay. Now, what are non-numeric values? You see, generally, when we get a data to make a model, to work on it, to try and analyze the data, we generally receive those data from surveys or from some sites using web scraping tools or something, right? Okay, so when we do that, there is bound to be some error in the data. There can be a chance that that somebody would have written not applicable in their what say backlogs. Right now, considering that I'm going under through the whole placement process, we have to fill multiple forms in which we have to specify do we have backlogs or not. So, some students tend to write zero, okay, the numerical value of zero. Okay, that's fine. If we have to calculate the average inside of a list, or even inside of a row value or a column value, if we get zero as the input inside of that, it's feasible, right? It's workable. We can work with a zero. But what if we put it a nan value? Nan value is basically a string literal. Okay. So if we add that value inside of that row or column, then that makes it difficult for us to perform arithmetic operations on it. We cannot find the average of the whole values present inside of that row or column, right? So we need to remove them or just replace them altogether, right? So that's what we will try here. Remove rows in NumPy array that contain non-numeric values. Okay, so let's start. We have to remove the rows. Call LSD3 is equals to never mind. List doesn't have that np.nan function. So if I put in any value as np.nan, I would need to give it as a string. So that would define the whole purpose itself, right? All right. So I have written this somewhere. Wait a second. So np.array. Okay. So you can see this is a multi-dimensional array, right? Basically matrix, right? So in this matrix we have two rows in which we have the np.nan elements. Okay. If I print dot shape comma ar, let's see, I'll just print it in the next line. Okay, you can see this is a 5 cross 4. 4 cross 5 in mathematical terms. 5 columns and 4 rows. One second. See, one, two, three, four, 5, and one, 2, 3, 4. Okay. Okay. Okay, fine, whatever. So we have two rows inside of this whole matrix, which has the NaN value. Okay, initially we did it as np.nan, but here it's printed as nan value. Okay. Uh, this np.nan inside of the numpy library signifies this nan character, which would be printed whensoever it is signified. Now don't consider that this is very useless, that whensoever it's occurring it will cause an error for us. No. Sometimes it is also used as a placeholder when they are just empty values inside of an Excel sheet or our data sheet. So we use this nan keyword to replace these things, or say generally I ask a class to fill out a form, and in that form instead of writing in their age, somebody accidentally typed in some gibberish. Okay, now I do not know who that person is, I just asked them to fill in their dates. Okay, now while their ages in years. Okay, so while doing that somebody filled out some gibberish. Now I do not need that value, right? But I cannot make it empty. Yes, I can put in 0 there, but initially we can also put in nan there as an alternative, just to make the data look cleaner and neater. Okay. Now, see, I have this whole thing, and now I just need to remove these two things. Why am I doing with this matrix of this vast dimensions? Because basically, whensoever we will get this kind of value inside of our matrix or data, we won't know their actual position, right? We just know what their value is. Their value is np.nan. Okay, I do not know what their position would be. So how would I remove them? Okay, now let's work on that. Okay, I don't want something, so I'm using the negation sign. Okay, now I know this is nan, so I'll ask, is it nan? By using the dot is nan method. Now, inside of what am I asking? So I'll have to put in my array name. Okay, then what access? That basically dot any access equal 1. Okay. Now let's see what the output is. It entirely removes the NaN values. Now consider if we would have to use the for loop for this. We would have to check each and every element inside of the matrix to see, okay, is this nan? Okay, if this is nan, remove this entire row. If this value is also nan, remove this entire row. This is a very small example, right? But consider if it had n number of rows, like 100 rows or something. The time complexity of that whole code increases multifold, right? It increases so much that if we are working in some competitive exam, it will just show us an error saying that no, it exceeded the time limit, right? So we need to use those kind of things to make our work easier. Now, find the most frequent value in a NumPy array. Okay. If we were to do this question using normal Python tools like the list, dictionary, for loops, and all, how would we do? Say I have a list uh, is equals to mm, okay. Now I want to know which element is repeated. Like there are elements who are repeated multiple times, right? See, 2 is repeated multiple times, 1 is repeated multiple times, 23 is repeated multiple times, and so on. Okay, so the question arises, how do I find how, like, which elements are repeated, and how do I check which element is repeated the most? Okay, so what would I do? I'll create a dictionary. Okay, I'll create a dictionary. Now, after creating a dictionary, I'll iterate through my list and say for I in list 4, if DC I A maximum is equals to max dot DC dot items. Wait. Okay, yeah. I used items instead of values. Okay, so I need to convert the DC dot values into a list. Okay, so I get my list of all the elements. Okay, now I'll print maximum of this max list. Hmm, 1 second. Okay, so this is printing the maximum frequency. Okay, this was printing the maximum frequency instead. 1 second. My list, my dictionary creates the repetition values, right? Each element of this list becomes a key. Okay, and this key will get its frequency value. These values for each of the keys are the values of its occurrence. Okay, now I need to find which key has the maximum occurrence. Now, prior to this, I was getting 3 as the output, as that was the maximum frequency. Now, I don't want the maximum frequency, I want the key of this maximum frequency, right? Okay, so what would I do? Mm, I'll use the dot get method. Okay, how will that work? I have my max function, right? I'll print max my dictionary DC, the iterable, then my dictionary dot get. I get the output as 2. Okay, since 2 was occurring thrice, as we had earlier seen. So, as you see, this takes up quite a lot of code, right? In counting which value has the most occurrences. Now, what if I have this list but I do it with NumPy? What would I need to do? There is this function called as bin count, which will count the frequencies, the occurrences of each element in the array, and then we'll apply argument max. Now, this method will have a maximum number of occurrences, like whichever element will be having the maximum number of occurrences, that element would be printed. How would I use this? Okay, now I'll just one second. Yeah, okay, I already have this. I'll print np dot bin count my list. Wait, I would need to convert this list into an array, right? np dot array list 4. Okay, dot argmax. Okay, now since argmax is also a function, I will get the parenthesis, and this whole thing has been reduced to a single line of code using NumPy. Okay, understood? Now let's talk about eigenvalues of a matrix. Those who would be in the third year and like would have a bit of knowledge from their preparational times, you would know what eigenvalues of a matrix is. Okay. If not, I'll still explain it in a bit. Okay. Okay, to speak about eigenvalues and eigenvectors, we will talk about matrices. You would have come across matrices in your 12th standard and even in the second semester, I think, in the second semester maths too, there would be a chapter regarding matrices. If then not, then ES and LA will be a subject for the second year students in which we will go in depth regarding these things, eigenvalues, eigenvectors, characteristic equation, what all do these things mean. Okay, so when we are talking about general maths, it's basically eigenvalues are the roots of the eigen equation, the characteristic equation. Now, then it entails the question that what is a characteristic equation? Suppose we have a matrix A. Okay, suppose we have this matrix. One second. Yeah. Suppose we have this matrix A and I write it as something like this. Okay. Okay. Now I have this matrix. It is a. Oh, okay. I'll just remove one element from each of the sublist. Okay. Now, this is a 3 cross 3 matrix, right? Now, I have this matrix. This is a normal simple matrix. What is the eigenvalue of this matrix? How would we calculate that? We will calculate the eigenvalues or the lambda values. Lambda values are used to denote the eigenvalues. Okay. So, how do we do that? By formulating this determinant, we calculate this equation, that determinant of a minus lambda into I equals 0. Now, what is lambda into I? I is the identity matrix, and identity matrix will have the same dimensions as your A matrix. Okay, so we will get an equation that would be somewhat like 10.5 minus lambda, 22.5, 0.8, and so on and so on. In each of these rows, we will have a lambda value being subtracted with one element in the diagonal of the matrix. Okay, then we'll calculate the determinant of this whole matrix. When we calculate the determinant of this matrix, we'll go into cofactor expansion of this whole determinant, right? So when we do that, in the end, we obtain three equations. Since this is a 3 cross 3 matrix, we'll obtain three equations, and then we will solve for 0 and calculate what are the roots of each of these equations, and those would be the eigenvalues. Since this is a 3 cross 3 value, 3 cross 3 matrix, there will be three eigenvalues, and hence there will be three eigenvectors. What exactly is the concept behind eigenvalues and eigenvectors is simple. That, see, there is this matrix we have given. If it goes under linear transformation, it will what are the eigenvectors of this matrix? Eigenvectors would be the vectors which will not change in dimensions but be multiplied by a scalar factor. Like they'll be scaled, they won't change their position. If I have a graph and I have created two vectors in the x and y axis, and when I do some sort of linear transformation, I may end up changing the locations, like the endpoints of my both vectors. Say y vector's endpoint might change to some other location. Okay, but the eigenvalues or the eigenvector, what they do is that these vectors are unique to that matrix, that they do not change their endpoint location, but they just get scaled up or scaled down. That is, that they can have positive values and they can have negative values. Okay, this equation, determinant A minus lambda I is equals to 0, is our characteristic equation. And by solving the roots, by getting the roots of this equation, we will get the exact value of our lambdas, lambda 1, lambda 2, and lambda 3. Now, if we go on to follow the procedure behind it, like how we'll do it in a mathematical sort of way, it will take a lot of time. Just consider this whole process of calculating the determinant of a matrix. Okay, even our calculators, even the top tier calculator is not able to calculate the determinant of a matrix in which there are some variables stored, right? So how can we find the eigenvalues using a numpy library? That's what we'll try and do. See, there is this all these all concepts like the matrices or arrays, arrays being one-dimensional matrices, they all come under linear algebra. So inside of NumPy, there is something called as linear algebra, and I'll import that as algebra ALG, right? Yeah. Okay. First and foremost, I'll import my linear algebra packet inside of my whole NumPy library as LA. Now, inside of LA, I have a built-in function to get me the eigenvalue of any matrix. Okay. But what we have to take into consideration is that the matrix should be a square matrix. It cannot be of unequal dimensions like 2 cross 3 or 3 cross 2. It should be 3 cross 3, 2 cross 2, and so on and so on. Okay. All right. If we calculate the one second. Okay. Let's take my eigenvalues as LA. LA is signifying my linear algebra, and I'll get my function I vals. Okay, and I'll input my matrix inside of it. Okay. As simple as that. Those complete calculations, if we would need to do this question in C++ or without using NumPy, it would become a lengthy and tedious process. Okay. So I hope by going through today's session, you will understand how NumPy adds on to the benefits that Python already provides us, and how it reduces the time complexity of our code. Like if you consider this question, given space separated list of numbers, we print a reverse numpy array with the element type float. We had used a float method. We used a for loop to convert individual elements into float. We could have used the map function also, but even in doing that, there would be a time complexity, right? But using this, it reduces all of that. Okay, if that is not sufficient, let's consider this code. This whole code is taking a for loop inside of it, right? Then we are using other methods also, other functions also to calculate, get the key value, right? So instead of doing all of that, we calculated the key, we got the element with the maximum frequency in a single line of code, right? So even if you don't know how to calculate the time complexity of a code, you can see by yourself that how much the code has reduced when we are using NumPy or when we are using normal functions present inside of a Python module, like Python. Okay, so I hope you understand, and this was a fruitful session for you all. I'll be ending the session now, and I'll give an assignment which would be somewhat would be an upgrade of these questions that we have done right now. And yes, they would be available to you on internet, but please don't go off about doing that, like copying everything of it. These are questions which are basically very easy because right now you're just doing normal questions to solve simple concepts, right? But you're not handling data or something, right? So it would be pretty easy for you guys to do, and I hope it would be nice that you guys do it with honesty. Okay, thank you so much for your time.